Hello there. Let us continue solving questions on iteration statements. And in this video, we will focus our attention to the questions where we are supposed to extract digits from a number. Now, before I get started with the first question from the list, let me show you the code that will help us in extracting each digit from a number. And what you see in front of you is that piece of code. This piece of code will help us in extracting each digit one by one from a number, assuming that the number is stored in the variable called n, right? So the first thing that I want to do over here is dry run the code taking some value of n so that you understand what's exactly happening over here. So let me do that by taking the value of n as, let's say, 1256. Now, n is 1256, and this is a while loop. Since this is a while loop, this will be governed by a condition, right? And since this is a while loop, the condition would evaluate first before the body gets executed, right? So the condition is n not equal to 0, and n is 1256, which makes this condition true. And since this condition is true, the body will be executed. Now, there are two statements in the body of the while loop. The first statement is last digit is equal to n mod 10. And the next statement is n is equal to n by 10. So if you see, what's really happening over here is n is getting divided by 10, right? In the first statement, the remainder is taken. And in the second statement, the quotient is being taken, right? So with this clear, let's understand what is happening in each of these statements and what will be the output or the result when these two statements are executed. So the first statement is last digit is equal to n mod 10, which means n, which is 1256, will get divided by 10, and we will get 125 as the quotient and 6 as the remainder, right? So this 6 will get stored in the last digit variable. So let me write it down over here. Let me say LD instead of last digit. Let me say 6. So this was the first statement in the while loop. The second statement is n is equal to n by 10, which means n will be divided by 10 and the quotient will be collected. And we know the quotient is going to be 125, right? So n will be changed from 1256 to 125. So at the end of the first iteration, this is what we will have. The LD or the last digit will contain 6 and n will contain 125. And once the iteration ends, what happens is the condition is checked before the body is executed again, right? So the condition is n not equal to 0 and n is 125, which means this condition is still true, right? Now, since the condition is true, these two statements will get executed, which means n will be divided by 10. And in the first statement, the remainder will be taken. In the second statement, the quotient will be taken, right? So we will have 125 divided by 10, giving us 12 as the quotient and 5 as the remainder, right? So what is going to happen? This 5 will go to last digit and this 12 will go to n. So now last digit becomes 5 and n becomes 12, right? So before we go to the next iteration, take a pause and take a look at what we have so far in LD and n in each of these iterations. So n was originally 1256. In the first iteration, we got 6 in last digit, which is the last digit of the original value of n, right? In the next iteration, we got 5 in the last digit, which is the last digit of the modified value of n, which got modified after the first iteration. And when I say modified, I mean the last digit was dropped from here. But if you consider the original value of n, the first value in LD is the last digit of the original value of n. And the second value in LD is the second last digit of the original value of n, right? And this must have given you an idea of what is going to happen in the next iteration. In the next iteration, because n is 12 and this condition is true, these two statements will get executed where 12 will be divided by 10 and we will get 1 as the quotient and 2 as the remainder, right? This 2 will go to the last digit and this 1 will go to n, right? So we will put 2 over here and 1 over here. Now the value of n is 1. The iteration ends, which means the condition will be checked again before the next time the body is executed, right? Now n is 1 and 1 is not equal to 0, which means the condition is true. So these two statements will be executed again. And this time 1 will get divided by 10, giving us 0 as the quotient and 1 as the remainder. So last digit will be 1 and n will be 0. And with this, we are at the end of the fourth iteration. And here the value of n is 0. So this time, this condition will give us false because n is equal to 0, but the condition is n not equal to 0. And since this is false, the body won't be evaluated again, right? And the loop will terminate and the control would flow to the immediate statement that is following the while loop, right? So take a look at the values that we have in LD in each iteration. And like we discussed earlier, in the first iteration, LD will store the last digit of the original value of n. And in the second iteration, it will store the second last digit, right? In the third iteration, it is storing the third last digit. And in the last iteration, it is storing the last digit of the value that was originally in n. And to be able to do that, we reduce the value of n in every iteration. And when I say reduce, I mean getting rid of the last digit in each iteration. So originally it was 1256, it reduced to 125, then it reduced to 12, and then it reduced to 1, and then finally to 0. And once the value of n has become 0, there's no point going for these two statements, right? Because if it is 0, it means that we have extracted all of the digits, right? And that is why it has reduced to 0. And that is why the condition is n not equal to 0. So I hope this is clear. Now, before I jump and start solving questions, there's something important that I wanted to tell you. Over here, we have discussed an approach using which we can extract each digit from a number, right? In the approach that we have discussed, we are starting from the last digit, that is the digit at ones place, and then going towards the left, that is from ones to tens to hundreds and then to thousands and so on, right? And you may be wondering that is it the only way in which we can extract digit? That is, should we be extracting from the last digit and going towards the first? Can we not extract from the first digit and go towards the last? Well, we can. And I've discussed that in a separate video, which you can access by clicking over here. In that video, I have discussed both of these approaches. That is, extracting digits from the last and going towards the first, and extracting digit from the first and going towards the last. And I've also discussed why is extracting digit from the last and going towards the first better approach. To summarize, it is better because this approach involves lesser calculation. And the other approach, where we will start extracting from the first and go towards the end, will involve more calculation. So more calculation means more time that the program will need to do the same task. So with all of that discussed and with us being clear on how to extract digit from a given number, let us continue and let's solve the first question from the list, which is given an integer n, print all the digits of n. Now, before I write code, let me come back over here and let's see how can we approach this question. Now, the question is to print each digit that is there in the given value, which is stored in the variable n, right? And we know how can we extract each digit. And if we can extract each digit, we can print it also, right? So what changes will we have to do over here to be able to print all the digits? Now, each digit that we are extracting is in the last digit variable, right? So once we have the last digit, can we print the value that is there in the last digit? Will that help in solving this question? It will, right? And keep in mind that the question did not specify whether we should be starting from the digit at ones place and then going towards the left, or should we be starting from the first digit in the number and going towards the last. And since the question does not specify that, we are free to choose whatever we want to. So for this question, let us start from the last digit and go all the way towards the first digit, right? And like we have discussed, the only change that we will have to do in this code is to print the value of last digit once we have that value available with us, right? So let's come to IntelliJ, and over here I have a package called src, inside which I've got a package called iteration statements, inside which I already have a package called questions, which I had created in the last video, where I had solved basic questions using iteration statements. And all of those questions are in the fundamental loop patterns package. And what am I going to do now is I'm going to create another package, and I'll create this package in the questions package. And I'll name this package as digit extraction pattern. Now, inside the digit extraction pattern package, I'll create a Java class, and I'll name this as q1 underscore print all digits of n. And I'll have a main method. Now, on the basis of whatever we have discussed, we will of course need n, and let's take n as 519, say 35, or 519035. And over here, I'll have a while loop. The while loop will say while n not equal to 0, then I'll extract the last digit using this operation, n mod 10. Then I'll reduce the value of n so that n is ready to extract last digit in the next iteration, right? And on the basis of whatever we have discussed, we will just have to print the value of last digit. And if we do that, we will be able to print all digits of n. Now, this system.out.println statement can be here or here, doesn't matter. So let me put it here and run the code. And the output that we have is 530915, which is this, the digits getting printed from the last to the first, right? And even if I take it from here and put it right after this statement, that is int last digit is equal to n mod 10, we will get the same output. So we have got 530915, which is the digits getting printed from the last to the first. So this code is working absolutely fine, right? Now I've taken only one value of n, and I have checked with just that value of n. But I would recommend that you write this code, take a few different values of n, and see if it is working fine. So with that discussed, let me mark this question as completed, and let's move on to the next question. And the next question is, given an integer n, we need to count the number of digits in n. So first of all, let us discuss how can we solve this question, right? So let's come back over here. Now over here, we have to count the number of digits in n, right? Which means we will have to extract each digit and keep a track of how many digits we have extracted so far, correct? Now we already know how can we extract each digit, and we can do that with the help of this code, right? So what changes will we have to make over here to be able to count the number of digits? Well, can we do it this way, that once we have extracted a digit, we increase the value of count to indicate the number of digits that we have extracted so far? Can we? Well, let's see. So let's say we have a variable called count, right? Which will initially be 0, of course. And the reason is count being 0 initially will indicate that no digit has been extracted so far, right? Count should be updated to 1 if and only if we have extracted one digit. And it should be updated from 1 to 2 if and only if we have extracted two digits so far, right? So taking this into consideration, that is having another variable called count, which will be set to 0 initially, can we do it this way? Once we extract the last digit, that is 6, from the original value of n, can we say that count is 1? Once we extract 5, that is the second last digit of the original number, can we increase the value of count from 1 to 2? We can, right? And so far, it seems to be working well. Count being 2 over here indicates that we have extracted 2 digits so far. Similarly, count will be 3 here and 4 over here. And when the loop terminates, that is, the condition finally becomes false when n is equal to 0, count will hold 4, right? And count holding 4, indicating that there are 4 digits in the number, is absolutely right, correct? So what will we have to do over here? We'll have to introduce a variable called count. and we will initialize this to 0, right? And in each iteration, we will have to just increase the value of count by 1, right? So let's go back to IntelliJ, and over here, let me create a new Java class. Let me name this as q2 underscore count number of digits in n, right? Now, to solve this, I'll grab whatever we have here in Q1 solution and I'll paste it. So I'll keep the value of n as it is, and all of this will remain same. The one thing that will change is introducing a new variable, which is count. And over here, I will just increase the value of count by 1. And at the end of the loop, I will print the value that is there in the count variable, right? And also, we don't need this println statement in line number 10 because we are not supposed to print the digits this time. All we are supposed to do is count the number of digits in n, right? So let me get rid of this. Now, as soon as I get rid of that statement which printed the last digit, you would observe that there's no usage of last digit over here in this code, right? So let us leave it as it is for now. Let's run the code and check the output. And then we will also remove this statement because as you can see, this is not being used. And in this question, by the way, all we are supposed to do is just count, right? So we just need to reduce the number in every iteration until that number becomes 0. Last digit will not be used over here because we are not processing that digit. Count will increase by 1 irrespective of what last digit contains, right? So if I run the code, I expect 6 as the output, and that is what we have. And if I change the value of n to, let's say, 5135, I should get 4, and that's what we are getting, right? Now, let us finalize the code, and let's remove the statement in line number 9. So with this, if I run the code, I should get the same output, and that's what is happening over here. So this code seems to be working perfectly fine. So we can mark this question as completed too. Now let's move on to the next question, which is given an integer n, count the number of even digits and number of odd digits in n. So this looks similar to whatever we did just now, which is count the number of digits. But there's a small tweak over here, which is we have to count number of even digits and number of odd digits, right? So let us discuss how can we solve this question. For that, let's come back over here and let's take a look at whatever we have. So n is 1256, and using this logic, we were able to count the number of digits. Now, we have to count the number of digits, but then we have to count number of even digits separately and number of odd digits separately, right? So for that, first of all, let me get rid of this. Now, because we are expected to count number of even digits separately and number of odd digits separately, we'll have to take two variables, right? Because we'll have to keep track of two counts. So even count and odd count. And similar to the explanation that we had in the last question, both even count and odd count will be initialized to 0, indicating that we have not encountered any even or any odd digit so far, right? Only when we encounter an even digit, we will update this to 1 and then to 2 and so on. Similarly, only when we encounter an odd digit, we will update this to 1, then 2 and so on, right? So we will need two variables. That is clear. Now, what we have to do to be able to accurately track if it is an even digit or an odd digit. So we will be able to extract each digit one by one, right? Now, once we have that digit extracted, can we check if it is an even number or not? We can. So once we have the last digit, can we do something like this? LD mod 2 is equal to 0. And since LD mod 2 is equal to 0, it means it is an even number, which means even count should be increased by 1. So can we say even count plus plus, right? And if it is not the case, that is LD contains an odd number, we will increase the value of odd count by 1, right? So these are the changes that we will have to do to be able to keep account of the number of even digits in a given number and the number of odd digits in that number, right? So with this clear, let's write the code for this. Let's come back to IntelliJ. Let me close this and let me create a new Java class. Let's name the Java class as q3 underscore count number of even and odd digits in n. So what am I going to do next is grab the main method from the solution of Q2 and I'm going to paste it over here. Now we have got n and we won't need count. We will need even count and we will need odd count, right? And now over here, as we have discussed, we will also need the last digit, right? So we will bring that statement back in this question. And let me get rid of these statements for now. So with this code, what we will have to do next? Once we have last digit, we will have to check if last digit is an even number or an odd number. And we'll have to increase even count by 1 or odd count by 1, right? So let's put that check over here. We'll say last digit mod 2 is equal to 0. If that is the case, even count plus plus. Otherwise, odd count plus plus. Now again, whether you put this piece of code here or just after this statement does not matter. It will work absolutely the same, right? So with that clear, the only thing that we have to do now is print the values of the variable even count and odd count, right? So if I run the code now, what do we expect? We expect odd count to be 4 and even count to be 0. And that is what we are getting. Now, if I change this to, for example, 5145, I should get odd count as 3, even count as 1, which is what we are getting. So this code seems to be working perfectly fine. So let's mark this as completed. Now, with this clear, let's move on to the next question. And the next question says, given an integer n, we need to find the sum of digits of n. Now, this is similar to what we had done over here. That is, given a positive integer n, we need to find sum of all numbers from 1 to n. So if you already know how to find sum of all numbers from 1 to n, great. Please proceed from here and I'm sure you'll be able to understand the explanation. If not, you can access that video in which I have discussed this by clicking the card that is appearing over here and then going to the relevant timestamp. So let's come back over here and let's discuss how can we find sum of all the digits of n. Let us take a look at this. Now over here, what we had discussed the last time was how can we find the count of even digits and count of odd digits. So let me get rid of all of this first. And let's check how can we find the sum of digits of n. So we will be able to extract each digit one by one, right? So first time we will get 6, then we will get 5, then 2, and then 1. So if I have 6 first, and then 5, and then 2, and then 1, what would the sum be at the end? So can we do it this way? Can we have a variable called sum and initialize this to 0? And then what we will do is every time we extract a digit, we will add this digit to the value of sum in that iteration, and then we update the value of sum. What do I mean is, I extract the last digit, which is 6. Sum in that iteration is 0. So sum will become 6. Why? Because we have got one digit, right? And taking just that digit, the sum will be 6. Now in the next iteration, what is going to happen is the last digit will be 5. So what should the sum be? We already encountered 6. Now we are seeing 5. So sum should be 6 plus 5, right? Now we already have 6 in sum because we encountered 6 in the first iteration. So this time, what are we going to do is add 6 and 5, which will give us 11. And we will update the value of sum to 11. Then in the next iteration, we will get 2. So we will go for 11 plus 2, which will be equal to 13. And in the next iteration, 13 plus 1 will give us 14, right? So what we will have to do to be able to find sum of all the digits of n is this. We will need a variable called sum, which will be initialized to 0, right? And once we have the last digit, all we will have to do is this. We will add the last digit to the value of sum in that iteration, and we will store that back in the sum variable. So we know that writing sum plus equal to LD is the same as writing sum is equal to sum plus LD, right? So with this change done, we will be able to find the sum of all the digits of n. So with this clear, let us come back to IntelliJ, and over here, let me close this. Let me create a new Java class. Let me name this class as Q4 underscore print sum of digits of n. And what am I going to do is I'm going to grab the main method from the solution of question 1 and paste here. Now, like we have discussed, what will we need to do? We will need a variable called sum, right? Which will be initialized to 0. Now, we won't need to print the last digit. So let me get rid of the statement in line number 10. And once we have the last digit, what we will have to do is we will have to do this. Sum is equal to sum plus last digit. Now, this statement will keep a track of sum of all the digits that has been encountered so far, starting from 5, then 8, then 8, then 17, and then 18, and then 5 is 23. So at the end, we should be getting 23 as the output. So let's run the code and check. And that is what we are getting, right? Now, if I change this to, for example, 519, say 235, we should be getting 25 as the output. And that's what we got, which means this code is working absolutely fine. So we can mark this as done, right? Now, the next question is, given an integer n, we need to find the product of digits of n, which is similar to finding the sum of digits of n. The only difference is we're finding the product, right? And not the sum. So if I come back over here and ask you what changes will we have to make to this code to be able to find product, what will your answer be? Pause the video for a moment, write your answer in the comments and let me know. So let me first of all create a new Java class. Let me name this class as Q5 underscore print product of digits of n. And what am I going to do is grab the main method from the solution of Q4 and paste here. Now, what we need to do is we need to find product. So let me first of all change all of the occurrences of sum to product, because that would be a more suitable variable name. Of course, variable name is not important considering what we are going to store. As in, variable name won't determine what are we going to store in it. We can name it anything, for example, XYZ, and it would still work absolutely fine. But the convention says that the variable name should indicate what it is holding. And taking that convention into consideration, I've renamed this to product. Now, what will we have to change here? We'll have to change this plus to asterisk, right? Because we are supposed to find the product. And what's another change that we will have to make? We will have to initialize product to 1 and not 0. And again, if you already know why did I initialize to 1, great. If not, you can watch the video that's appearing over here and jump to the relevant timestamp where I had discussed this question. Over here, I had discussed why should product be initialized to 1. So with this change done, if I run the code, will I get the correct output? Well, let's find out. So I've got 5 multiplied with 1 is 5, multiplied with 9 is 45, into 2 is 90, into 3 is 270, into 5 is 1350. So if I run the code, I should get 1350, and that is what we are getting, right? But if I change this 2 to 0, I should get 0 as the output, and that's what I got. So this code seems to be working perfectly fine, right? And because it is working fine, let me mark this as completed. Now let's take a look at the next question. And the next question says, given an integer n, check if n is an Armstrong number or not. So to solve this question, the first thing that we will have to do is understand what Armstrong number is, right? So let me Google search Armstrong number and let's read what it has to say. It says that an Armstrong number is a positive integer which is equal to the sum of its own digit, each raised to the power of total number of digits. So let me explain what that means. Now, this says that 153 is an Armstrong number, and it is because when we take each digit of 153 and raise it to the power of the number of digits in 153, which is 3, we will get the same number, which means 1 cube plus 5 cube plus 3 cube will give us 153, which is the original number itself. And that is why it is an Armstrong number. If we take a 4-digit number instead, let's say 1534, we will be going for 1 power 4 plus 5 power 4 and so on, right? So to understand Armstrong number better, let's come back here. So what did we discuss? We discussed that if we have got a 3-digit number, we will have to do this first. We'll have to go for each digit raised to the power of total number of digits, right? And then we will have to add them up. Now, if this is equal to the original number, then this is an Armstrong number. But if this is not equal to the original number, then that is not an Armstrong number, right? Now, if this was a 4-digit number, for example, 1534, we would have to go for 1 power 4 plus 5 power 4 plus 3 power 4 plus 4 power 4 and check if whatever we get here is equal to 1534 or not. And then we will be able to say if it is an Armstrong number or not, right? So to be able to solve this, what will we have to do first? First of all, we will have to find the number of digits in the given number. And we already know how to do that, right? So now assuming that we know how to find the number of digits in a given number, what will we have to do next? Next, we'll have to iterate over the given number and extract each digit one by one, right? So once we have the digit, which is 6 in the first iteration, what we will have to do is we'll have to go for 6 power the number of digits. Let's say it is d, right? And then in the next iteration, we would be going for 5 power d, assuming the next digit is 5. Then we would be going for 2 power d and then 1 power d, right? And this is what we will ultimately have: 6 power d plus 5 power d plus 2 power d plus 1 power d. So over here, what are we ultimately doing? We're taking a few numbers and then we are adding them up, right? This is similar to the question that we have discussed already. So if we come back and check what we have to do now, which is to determine if n is an Armstrong number or not, we will need to use whatever we have discussed in this question, where we are counting the number of digits in n, and this question, where we are finding the sum of all the digits in n. Except that we are not really finding the sum of digits in n, we are finding the sum of digits raised to the power of number of digits in that number, right? So taking this into consideration, what changes will we have to make over here to be able to find Armstrong number? So the first thing that we will have to do is find last digit raised to the power digit, right? Of course, this will be after finding the number of digits and let's say storing in a variable called d. So once we have the number of digits, we'll have to find the last digit power d, right? And we will also have to find sum. So we'll need another variable. So taking n as 1, 2, 5, 6, the number of digits would be 4, which means d is equal to 4. Now when the iteration starts, last digit will be 6 first, right? So it will say 6 power 4. Now 6 power 4 will be 6 square into 6 square, which is 36 into 36, which is 1296. So sum will be initialized to 0. It will become 1296, right? Then we will have 5. So we'll go for 5 power 4. It will be 5 into 5 is 25 and 25 into 25 is 625. Similarly, we'll then get 2. So 2 power 4, which will be 16, and then 1 power 4, which will be 1. Then we will add all of this and then check if sum is equal to the original number or not, right? So once we have sum, this is what we will have to do. We have to check if sum is equal to n, right? Now, before I write the code, I want to bring your attention to this point. We started with n is equal to 1, 2, 5, 6, right? But then in each iteration, we are changing the value of n. But according to whatever we have discussed, this is what we'll have to do at the end. We'll have to check if the sum that we got when we did this is equal to the original number or not. But as you can see, the original number was 1, 2, 5, 6. But at the end of the iteration, the original number has reduced to 0. So how will we be able to do this? To be able to do this, we will have to preserve the original number, right? Now, how can we preserve the original number? We can preserve the original number by making a copy of it. So can we say n copy or say nc? So if we do this, what's going to happen is nc will also contain 1256. Now, going by the logic that we have discussed over here, what's going to happen? N will be reduced to 0, right? But then NC will remain the same because we have not touched that variable at all, right? So over here, instead of saying sum is equal to N, can we say sum is equal to NC and then check? Yes, we can, right? In this case, we will get the correct result because NC should have been 1256 and it is 1256. But if we use N instead, N should have been 1256 for correct check, but N has reduced to 0 because that's what this operation does, right? So with all of this clear, let's discuss what changes will we have to make to this piece of code to be able to find if a number is an Armstrong number or not. So first thing we will have to do is calculate the value of D, right? Once the value of D is calculated, in each iteration, what will we have to do? We'll have to go for LD, which is the last digit, power D, right? And I'll tell you how can this be done in a moment. Now, whatever we have over here as a result of LD power D should be added to sum and it should be stored back into sum, right? Now, once this is done, at the end, what we will do is we will do this if NC, and before this is what we'll have to do. We'll have to make a copy of N and store in NC. So we'll say if NC is equal to sum, then we'll print Armstrong number. Else we'll print not an Armstrong number, right? Now, the last piece of the puzzle that we need to know to be able to solve it completely is how can we find LD power D? So for that, what am I going to do is I'm going to use an inbuilt function of Java to find LD power D. And that inbuilt function is called POW, which is in the math class. So we'll say math.pow LD comma D. And this will give me LD raised to the power D, right? So over here, we'll say math.pow LD comma D plus sum, and that will be stored back in sum. So with this clear, let's come back to IntelliJ and let me first of all create a Java class. Let's name this as Q6 underscore check if N is Armstrong or not. And let me have the main method over here. Let's take N as 153, for example, because we know that 153 is an Armstrong number. Now, the first thing that we will have to do is count the number of digits in N. And for that, what we can do is we can grab the code from here. So we'll copy this. We will come back over here and we will paste this. Now, at the end of this while loop, the count variable will store the number of digits in N, right? But as you can see, N is getting modified over here, but we need N again, right? So what we will do is we will say int N is equal to 153, but then in the next line, we'll say int N copy is equal to N. So whatever is there in N will be stored in N copy. Now we will replace the usage of N by N copy. And here. Now with this done, we will have the count variable containing the number of digits in N, right? So what will we have to do next is we will have to create a variable called sum, right? And sum will be initialized to 0. And we also know how to find sum. So what we will do is we will grab this, we will come back here and we will paste this. Again, instead of N, we will need to use N copy, but then N copy has been used over here, which means at the end of this iteration, N copy would be 0, right? So before we can start this loop, we will need to initialize N copy to N again. So what are we doing is we have N, which will contain the number 153. And then we will have N copy, which will be a copy of N, right? Now, when we found the number of digits in N, what did we use was the N copy variable, which means at the end of this iteration, N copy will be 0. So before we can go for another while loop over here, which is going to use N copy, we will have to initialize N copy back to N, right? So let me replace the usages of N with n copy. So with this done, at the end of the second while loop that we have, we will have the sum, but we don't need this sum. That is, we don't need sum of all digits. What we need is sum of digits raised to the power of number of digits that we have in n, right? So instead of going for sum is equal to sum plus last digit, what we will go for is last digit raised to the power of count. And we know that we can do that with the help of math.pow. And if I go to math.pow, you will see that it expects double and double, that is two double parameters. So if I say math.pow last digit, that is the digit that we have extracted in this iteration, then comma count. It is same as saying last digit power count. But the problem over here is POW method returns a value of double type. Now we will get to the details of what methods are and how they work later on. But for now, just understand that this POW method will do some operation and will give you double value. But over here, what are we doing is we are adding double with integer and then we are storing it back into integer. And you already know that this is not allowed, right? Because if it is allowed, we will end up losing some value because double can store decimal points, but integer cannot. Now, what we know here is last digit will be an integer, right? And we also know that count will be an integer. So if you have, say, 5 power 4, the output will also be an integer. That is a number without a decimal point, right? And since we know that is going to happen for sure, what we can do is we can typecast this, right? So we can say whatever math.pow is returning, typecast that to int. That means if it is returning, say, 125.0, give me 125 only. So once we have that, we will add sum to whatever is returned by math.pow and then store it back in sum. And then at the end of this loop, we can check if n, that is the original number, equal to sum, we will print yes, Armstrong. Otherwise, we'll say no, not Armstrong, right? So before I run the code, let me tell you what happened here. So we started off with n as 153, and then we made a copy of n because we are going to iterate over the copy of n to be able to find the number of digits in n, right? So this is what we did over here. Now the count variable will store the number of digits in n, which is what we will need later on, that is over here. So by the end of this loop, that is by the end of line number 13, we will have the number of digits in n in the count variable. Then what do we need to do is we have to iterate over each digit of n, and then we have to raise each digit to the power count. And then we have to find sum of all of those digits raised to the power count, right? Which means we will need n again. And what we have done is we have reinitialized n copy to n. And we have reinitialized because by the end of this iteration, n copy will become 0. So we reinitialize to get the original value of n. Now, once we have that, we also created another variable called sum, which is going to keep track of the sum. And then we started this while loop where we'll extract each digit from n copy, and then we will raise that digit to the value count. That is, if it is 153, we'll go for 3 power 3, then 5 power 3, and then 1 power 3. And then we will add all of them up using this statement. And at the end of this second while loop, what we will do is we will check if whatever sum we got is equal to the original number or not. If it is, we will say yes, Armstrong. Otherwise, we will say no, not Armstrong. And to be able to go for last digit raised to the power count, we used an inbuilt function that is there in Java, which is math.pow. Now, math.pow expects two double values. And if it expects double value, we can pass int. That is not a problem. But it also returns a double variable. And because it returns a double variable, and what are we doing is we are storing the sum in an int variable. We are typecasting it to int. And we are doing so with confidence because we know that last digit is int, count is also int. And if both are int, last digit power count will also be int, right? So even by accident, we are not losing any data over here. So with all of this done, now let me run the code and see if it is giving true or not. And it should giving true. I mean, it should give yes Armstrong as the output because 153 is an Armstrong number. So if I run the code, I get yes Armstrong. But then if I change this to 154, and you can try it out and check for yourself, 154 is not an Armstrong number. So I should get no, not Armstrong. And that is exactly what we got. Now, let me also prove my point where I said that by the end of this while loop, n copy will be 0. So all that I'll do over here is just print the value of n copy. And of course, I'll attach a message also so that it is easier for us to track. So if I run the code, as you can see, n copy is 0. And because n copy is 0, we reinitialize n copy to whatever was there in n, right? So with this done, let me remove the println statement first of all. Come back over here and let me mark this question. That is the one where we are supposed to check if a given number is Armstrong or not as completed. And let's move on to the next question, which is given an integer n, we need to find the reverse of n. So let's understand how can we solve this question. So for that, let's come over here and let's take n as 1, 2, 3, 4, and hence its reverse would be 4, 3, 2, 1. Now observe n and its reverse, and you'll notice something, which is the last digit of n becomes the first digit of reversed. The same thing applies to the second last, third last, and the fourth last digit of n, which will become the second, the third, and the fourth digit of the reversed number respectively, right? So it is like extracting each digit of n starting from the very last to the very first and then placing them in the same order to get the reverse number, right? What do I mean is, if I have 1, 2, 3, 4 and I extract from last to first, I'll get 4 and then 3 and then 2 and then 1. And if I place them in the same order, I'll get the reverse number, right? So we know how to go from here to here. That is how to take 1, 2, 3, 4 or any value of n for that matter and start extracting from the last digit to the very first digit of n. So we'll get 4, 3, 2, 1, 1 by 1 in each iteration, right? Now the next question is, how do we go from 4, 3, 2, 1, 1 by 1 in each iteration to 4,321? And the answer to that lies in how we read this, which is we read this as 4,321, right? So take a look at this. This is 4, 3, 2, 1 extracted one by one in that order. And what do we get is we get 4,321, right? So if we take this, which is the place value of each digit, and we add them up, what do we get? We get the number itself, right? Which means that if we have 4, 3, 2, and 1, 1 by 1, and we can then find its place value, and then the sum of those place values, we will be able to get the reverse number, right? So summarizing our discussion so far, if we have n is equal to 1, 2, 3, 4, and we can extract each digit from the very last to the very first, we will get these digits, right? And then if we can find the place value of each digit in the reversed number, and then we can add those place values, we will be able to get the reverse number, right? So we know how to go from here to here. Now let's discuss how to go from here to here, right? So let's take a look at 4 and its place value. Its place value is 4,000, right? Similarly, let's take a look at 3 and its place value. Its place value is 300. Place value of 2 is 20 and 1 is 1, right? Now, why is the place value of 4,000? It is because 4 is put at the thousands place, right? Now, why is 4 put at thousand place? Because 4 is the first digit we extracted from a 4-digit number. Now, since the original number is a 4-digit number, the reversed number will also be a 4-digit number, right? And if we have a 4-digit number, and if we are putting 4 as its first digit, it will be at thousand place only, right? So this is at 1000, this is 100, this is 10, and this is 1. Now, the question is, given n and a digit that we extract, how do we figure out what will be its position in the reversed order? So let's focus on 4 first, and then we will think about 3, 2, and 1 also. So 4 is at 1000 place because this is a 4-digit number. If this was a 5-digit number, for example, 21234, 4 would have been at 10,000 place, right? The same thing applies to if 4 was in a 6-digit number, right? So to be able to determine the place of 4 and therefore its place value, we will have to calculate the number of digits in the original number, right? And we already know how to do that. So let's say the value is stored in a variable called d, which is 4. That is, this is a 4-digit number, right? Now, if we have the number of digits, how can we determine what to multiply 4 with in order to get its correct place value? It will be 10 to the power 3, right? Because if the number of digits are 4, this is at 0 position, this is 1, this is 2, this is 3, right? So this will be 4 into 10 to the power 3. So if we know d is equal to 4, we can say 4 into 10 power 4 minus 1, which is 10 power 3, right? Similarly, 3 will be multiplied with 10 square. 2 will be multiplied with 10, and 1 will be multiplied with, not 0, sorry, 1 will be multiplied with 1, right? So as you can see, we can find out the place value of the first digit that we extract by multiplying that digit to 10 power number of digits minus 1, right? Now, for the first one, it is 10 power 3. So for the second one, it will be 10 power 2. Then for the next one, it is 10. And then for the last one, it will be just 1, which is 10 power 0, right? So if we can figure this out, we will be able to figure the others out also, because all of these are whatever was the value in the previous iteration divided by 10, right? This is 10 square, which is 10 cube by 10. This is 10, which is 10 square by 10. And this is 1, which is 10 by 10, right? So taking all of this into consideration, let's think how can we write code to be able to find reverse given n. So we know that we will have to extract each digit. So let me put the code for that first of all, right? So we will say while n not equal to 0, then we will say last digit is equal to n mod 10. And then we will say n is equal to n by 10. Now, as we can see over here, once we have the last digit, we'll have to do some processing, right? And then we will reduce the value of n for the next iteration. So let me leave some space over here. And then let's discuss what logic will be put over here. So as you can see, the last digit will be, first of all, multiplied by 10 raised to the power d minus 1, right? So let's assume that the 10 cube over here is x. So can we say last digit multiplied by x? We can, right? So we are going to get this last digit multiplied by x, where x is equal to 10 power d minus 1, where d is the number of digits in n, right? So with ld multiplied by x, we will get this, right? Now what's going to happen is, in the next iteration, the digit that we will extract is 3. And there we have to multiply 10 square to 3, not 10 cube, but 10 square, right? So if we keep on using this expression, that is ld multiplied by x, when x is initialized to 10 power d minus 1, what will happen? Even 3 will get multiplied to 10 cube, right? So what we will have to do is, like we do with n, we will have to make x ready for the next iteration, right? So if x is 10 cube here, for the next iteration, x should be 10 square, which is whatever value of x is there currently divided by 10 and then stored back in x, right? So what we will have to do here is, we will have to say x is equal to x by 10. So what is going to happen? X will initially be 10 cube. So 4 into 10 cube, right? Then we will reduce x to 10 square. So in the next iteration, it will be last digit, which is say 3 multiplied with 10 square, right? And that is how it will proceed. So we have figured out how to take care of this. That is the last digit multiplied with some number to get its place value, right? Now, once we have the place value, that is not sufficient because we will also have to add those place values to be able to get the reverse, right? So what we will do is we will take a variable called sum initialized to 0, and then we will do this sum plus LD multiplied with X, and then we will store it back in the same variable. And we already know why are we doing it this way, right? We are finding the sum of numbers that is coming one by one in a loop, right? So this is that code which will help us in getting the reverse of n given any value of n, right? So before I jump to IntelliJ and write code, let me dry run this code so that you see what's happening in each of these steps. So over here, what do we have? We have a few variables. First of all, we have got n, which is 1, 2, 3, 4. Then we have got x, right? Which is initialized to 10 power d minus 1. So if d is 4, x will be initialized to 1000. Then we have got sum. Then we also have the last digit, right? So over here, n is 1, 2, 3, 4. This condition is true. So last digit will be 4, right? Then we'll go for LD into X. LD is 4, X is 1000. So this will give me 4000. Now we have got sum to which we want to add 4000, and sum is initially 0, right? So it will be 0 plus 4000, which is 4000. So this statement is done. Then we'll go for X equal to X by 10. So X will become 100. And then N equal to N by 10. So N will become 1, 2, 3. Next iteration, this condition is true. So LD will be 3. Then this statement will be executed. So it will be LD into X. That is 3 into 100, which is 300, plus sum, which is 4000. So 4300. Then X equal to X by 10. So X will be 10. And then N is equal to N by 10. So this will be 12. So next iteration, condition is true. So what's going to happen is this will be 2. Since this is 2, LD into X will give me 2 into 10, which is 20. 20 plus 4300 is going to give me 4320, right? And then X will reduce to 1, N will reduce to 1. And the next iteration, the condition is true. So last digit will be 1. So LD into X is going to give me 1. 1 plus 4320 will give me 4321. And then X reduces to 0, N reduces to 0. And the next iteration, the condition is false. So the body does not execute anymore, right? And after this, if I print sum over here, it will print the reversed value of N, right? So this is how we can find the reverse of a number. So now with this discussed, let's go to IntelliJ. Let's close this. Let's create a new Java class. Let's name it as Q7 underscore reverse of N. And let's write the code. So what we have to do now is declare N and set it to some value. And the next thing that we have to do is count the number of digits in N. So I'll take this piece of code from the solution of question 2 and paste it over here, right? Now over here, you can see that we are using N, but we cannot because we need the original value of N for the next part of the code, right? So what am I going to do is I'm going to have a variable called N copy, and I'm going to say N copy equal to N. And I'm going to replace the occurrences of N over here with N copy, right? So with this, we have the number of digits. Now, what do we need to do next is we need to declare a variable called X, and we have to go for 10 power count minus 1, right? And we have discussed how to do that in this question. So let me grab this statement. Let me come back over here and let me paste it over here. Now it won't be last digit, it will just be 10. And it won't be 10 power count, it will be 10 power count minus 1. Other than this, I also need a variable called sum to find sum of the place values, right? Now, what am I going to do is I'm going to iterate. So I can say while n not equal to 0, I'll extract the last digit. So I'll say int last digit is equal to n mod 10. And then what am I going to do next is I'm going to say last digit multiplied with x, right? And then this is not sufficient. We'll have to add the current value of sum to it, and we'll have to store it back in the same variable sum, right? After this, I'll have to reduce the value of x by 10 so as to make it ready for the next iteration. And because of the same reason, I'll reduce the value of n by 10. Now at the end, if I print sum, this println statement should give me the reverse of the value that is there in n. So if I run the code, I should get 4321, and that is what I'm getting. Now, if I change this to, let's say, 1893012, for example, I should get 2103981. So I'm getting 2103981, which is absolutely correct. So this is how we can find the reverse of a number. Now over here, we have first of all calculated the number of digits that are there in the original value of n, which is fine. But then this is one extra step, which means the program will take a little longer to compute the reverse of n. Now my question is it possible to find the reverse of n without this extra step? That is, without counting the number of digits that are there in n. Well, there is, and let me discuss that with you. For that, let me come back over here and let's take n as 1, 2, 3, 4, right? Now, if n is 1, 2, 3, 4, and if we are supposed to find the reverse of n, we will have to extract each digit one by one for sure. Without doing that, there is no way in which we can find the reverse, right? So that means for any given value of n, we will be extracting each digit one by one, right? So let's say we extract 4 first, then 3, then 2, and then 1, right? Now take a look at the last digit and take a look at the value of n over here. So when we extract 4, it means we have read just 4. But when we extract 3, it means we have read 4, then we've reduced 1, 2, 3, 4 to 1, 2, 3, and then we are extracting 3, right? So if we do it this way, that whenever we extract a digit from n, we keep a track of the reverse so far, will we be able to get the reverse of the entire number? What I mean is this. When I extract 4, it means we have read only 4. So the reverse so far would be 4, right? Because we have read only one digit. But when we extract 3, if we can somehow, we'll get to how, but then if we can somehow keep a track of 43. And then when we extract 2, if we can keep a track of 432, and when we extract 1, we keep a track of 4321. By the end of this loop, we will have the reversed number in the REV variable, right? Again, when we extract each digit, we will keep a track of reverse until that digit. What I mean is when we extract 2, it means we've read 4, we've read 3, and we have read 2. So reverse would be 432, right? And then when we finally extract 1, the reverse would become 4321, correct? Now, the next question is, we know how to extract each digit, but how do we keep a track of reverse of the numbers that we have read so far? So for that, let's take a look at the values that we have over here, and let's try to find a pattern, right? So if you take a look at 43, we can write this as 4 multiplied by 10 plus 3, right? Similarly, we can write 432 as 43 multiplied by 10 plus 2. And then we can write this as 432 multiplied by 10 plus 1. Now, the 443 and 432 are not random values. The 4 over here is the value of reverse in the previous iteration. The same thing applies to 43. This 43 is the value of reverse in the previous iteration, and 432 is the value of reverse in the previous iteration. And all of them are getting multiplied by 10, right? And then lastly, we have got plus 3, plus 2, and plus 1, which is the digit that we have extracted, right? So in any iteration, we can keep track of reverse using this formula. The old value of reverse multiplied by 10 plus LD. And this will give me the new value of reverse, right? Now, what are we doing here is we are replacing the value of reverse in every iteration, which means we are multiplying reverse by 10 and then adding last digit and then storing the result back in the same variable, which means if I do it this way, if I say REV is equal to REV into 10 plus LD, this will be absolutely correct, right? So old value of reverse will be taken, multiplied with 10, last digit will be added, and then this will be stored back in the same variable, right? So going by this logic, we can solve for the second, third, and fourth iteration. But how about the first iteration? What will be the computation for the first iteration? So let's see if the same computation will hold here also or not. So it is reverse multiplied with 10 plus last digit, right? So over here, it should be reverse, which we don't know what it is as of now, multiplied by 10 plus last digit, right? So what value can we put over here such that this gives me 4? Can we put 0 over here? Yes, we can, right? Because 0 into 10 will be 0 plus 4 will be 4, right? Now, if we put 0 over here, are we violating anything? As in every calculation, this is supposed to be the old value of reverse. So if I put 0 over here, will this represent the old value of reverse? Yes, right? Because if we extract 4, which is the first digit we have extracted from n, this means that there was no reverse existing before 4 was extracted, right? So in that case, we can say that reverse is 0, right? So going by this logic, we can initialize reverse to 0. And then what we can do next is use that value multiplied by 10 and add the last digit to get the new value of reverse. And we're doing the exact same thing in each and every iteration. So going by this logic, we will be able to calculate the value of reverse of a given value in n without keeping track of the count of the number of digits in n, right? So let me quickly write the code for this. So the code will be something like this. While n not equal to 0, we will extract the last digit. Last digit will be n mod 10. And then we will say reverse is equal to reverse multiplied by 10 plus last digit, and then n is equal to n by 10. And over here, we'll create a variable called reverse and initialize to 0, right? With this logic, we will be able to calculate the reverse. So if this is clear, let's come back to IntelliJ, and over here, let's create a new Java class. But before that, let me refactor and rename this to say q7 underscore reverse of n solution 1. And let me create a new Java class now. Let's say q7 underscore reverse of n solution 2. And what am I going to do here is have a main method, take n initialized to 1, 2, 3, 4. Then what I need to do is take a variable called reverse and set it to 0. Then I'll need to start the while loop, say while n not equal to 0. Then I'll need to extract the last digit, which I can do so with the help of this, that is n mod 10. Then I'll say reverse is equal to reverse multiplied by 10 plus last digit. And then I will make n ready for the next iteration. And lastly, I'll print reverse. So if I run the code now, I should get 4, 3, 2, 1. And that's what we are getting. Over here, if I grab this and paste, I should get the same value that I got the last time, which is 2103981. And that is what we are getting, right? So this is another way in which we can find the reverse of a number without calculating the number of digits in that number, right? Now, let me come back over here. And here I've taken the variable called sum. And I've called it sum because I was finding the sum of place values of each digit in the reverse number, right? But then sum does not seem to be appropriate over here. So let me replace all of the occurrences of sum with reverse. So with this, let's come back here and let me mark this question as completed, which is given an integer n, find the reverse of n. And then let's talk about the next and the last question from the list, which is given an integer n, check if n is a palindrome or not. Now, before we can check if n is a palindrome or not, we need to know what a palindrome number is. So Let me Google search that first of all, and let's read the definition over here. Now it says a palindrome number is an integer that remains the same when its digits are reversed, which means if I take a number, say 1 to 1, and then reverse the digit, it will be 1 to 1, right? So the reverse number and the original number are same. And in that case, we can say that the number is a palindrome number. If we take 1, 2, 3, for example, the reverse would be 3 to 1. In that case, original number and the reverse number are not same. So we can say that it is not a palindrome number, right? So this means that to check if a number is palindrome or not, we will have to find its reverse first, right? So let's come back to IntelliJ. Let me create a new Java class. Let me name this as Q8 underscore palindrome. And what am I going to do is copy the main method from Q7 solution 2 and paste over here. So this will give me reverse of a number, right? But then what I have to do is I have to compare the reverse of the number with the original number. But in the code that I have written over here, the original number will get reduced to 0, right? So what I should be doing is I should be going for a different variable which will keep a copy of n, say n copy, and I'm going to use n copy instead of n, right? So I'll replace all of the n over here with n copy. And then instead of just printing reverse, what am I going to do is I'm going to check if n equal to reverse or not. If they're equal, I can print palindrome. If not, I will print not a palindrome, right? So if I run the code with this value of n, it will say not a palindrome. But if I change this to 1, 2, 3, 4, 3, 2, 1, and the reverse would also be 1, 2, 3, 4, 3, 2, 1, and I run the code, it will say palindrome. So this is how we can determine if a given number is a palindrome or not. With this, we have completed the last question from the list. So with this, we've come to the end of the video. Summarizing, we got to know about a pattern of question which we can solve using iteration statement, where given a number, we extract its digit and process each of these digits, right? So I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.